Good morning, good afternoon, good evening, everyone, depending on where you're joining us from today. And welcome to the world's most exciting classroom. My name is Joe Gorowski, and I will be your host for today. Now, we have an absolute jam-packed event, as always, today. The Oosterschelde, I think that's the first thing we should talk about, where it is, what's going on. So the ship has just left Cape Verde, and it's going to make its way across the Atlantic Ocean to the island of Fernando de Noronha. So that's going to take a little bit of time. So our next two world's most exciting classroom events will take place while the ship is at sea, and hopefully we'll be able to have live uplinks from the boat and see how everyone is doing on the sailing, see what kind of marine life they're seeing, and what kind of weather they're encountering as they're crossing the Atlantic Ocean. So we're hoping to have a little uplink at some stage during the event with Rodri and Tom from on board the Oosterschelde. But the last report I had from them said that the weather was a little so-so. So if they're having thunderstorms, we probably won't have the live uplink from the ship today, because the last thing you want to do is put up a big antenna to connect to a satellite when there's a thunder and lightning storm. So we'll keep our fingers crossed and we'll see if Tom and Rodri are able to beam in with us. And we'll get a little catch up on how the ship has been doing since it departed Cape Verde yesterday. Now, the ship was in Cape Verde. We had another amazing group of Darwin 200 leaders on board, and we're going to get to take a little look at one of their videos shortly. But before we do that, I want to share a little bit of footage here of the ship arriving in Cape Verde. So that was the ship arriving about a week and a half ago. And then we had 7 Darwin leaders come out to join the ship. And they were on some absolutely amazing conservation projects with Biosphera. And we did get to meet Alberto and Ali, one of the Darwin 200 leaders, last week. And we talked about one of the sea turtle projects. In fact, there were 2 sea turtle projects on the go last week. And we learned about the loggerhead sea turtles. And it is one of the top 3 spots for nesting loggerhead sea turtles. We know there's 7 species of sea turtles. 6 of them are threatened with extinction. So these kind of conservation projects are so important. So I mentioned 2 sea turtle projects. There was a shark and ray project. There was one for seabirds, one for endemic plants, one for rediscovering a lost reptile that was previously thought to be extinct, and one focusing on marine plastics washing up on these remote islands. So another huge variety of projects. One of our favorite words there, endemic, which we know means that it's found nowhere else in the world, just in that one location. So it's so important to protect those species. And then I've got a video clip I'm going to share a little bit later of that lost reptile. So it's always exciting when we think we've lost something, but we find a small pocket of them still surviving. So I mentioned we do have a Darwin 200 film today from one of our leaders, Merlin, and it's about seabirds on Razo Island. So let's play that now, and let's take a little look at what they discovered while they were out there on that conservation project.
Cape Verde is maybe famous in the minds of tourists for its white beaches and blue seas. However, Cape Verde has a wild side that often goes unnoticed. Its deserted volcanic islands contain a surprising variety of life. Consider Razo, a volcanic islet which forms a nature reserve together with Santa Lucia and Branco. With its 5 square kilometers of rocks and grass, it's a windy and hostile environment. However, it provides a home for many bird species, such as the endemic Razo lark. The island is also home for 7 seabird species, the highest number in the country. We're on Razo with Isabel Fortes. working for Biosfera as coordinator of the Birds program.
Porque aqui nós podemos encontrar várias espécies de aves marinhas, não só aves marinhas, mas também aqui podemos encontrar a espécie que até 2018 era endêmico do Ilhéu Raso, que é a caliandra, raso largo, mas nós reintroduzimos em Santa Luzia desde 2018, então agora podemos encontrar nos dois sítios.
Raso is also special for our captain and founder of Biosfera, José Melo.
Para mim o Ilhéu Raso, aliás não o Ilhéu Raso, mas Santa Luzia, Ilhéu Branco e Ilhéu Raso, para mim são quase como um deus. Como disse há pouco, pretendo-me reformar.
Our story is about the brown booby, a widely distributed seabird. Boobies are real seabirds, spending most of their lives at sea. They hunt for fish by performing spectacular dives from 15 meters high. On the cliffs of Raso, 2 breeding colonies exist. These seabirds play a vital role in the marine ecosystem, as they are at the top of the food chain. As top predators, they help regulate the population of their prey. Though Raso is home to many seabirds today, historical records tell us that today's population is only a shadow of what used to live here. This recent decline is mainly due to human predators.
Por exemplo, a cagarra, antigamente ela era capturada por vários pescadores que vinham de outras ilhas vizinhas, como por exemplo Santo Antão ou São Vicente, que eles apanhavam principalmente as crias para fins alimentares, comiam as cagarras.
Killing birds was common practice until very recently.
Sou cofundador da Biosfera e estamos nessa luta há 17 anos. Quase como uma brincadeira, fazer uma pequena exposição mostrando problemas ambientais em Cabo Verde. Começamos encontrando problemas que não nos despertava atenção. Apanha de areia, comer a carne da tartaruga, o peixe apanhado em espécie em grande quantidade, pequenos peixes apanhados sem controle de quantidade, lixo dos oceanos. Então aquilo nos acordou que tínhamos muito mais problemas ambientais em Cabo Verde do que aquilo que nós pensávamos ter. A partir daí resolvemos criar a Biosfera para essa luta que há de continuar.
What exactly does Biosfera do to protect the birds? How effective is this work when it comes to addressing current threats? In the next 2 episodes, I'm taking you on a journey to this deserted place to find the answers.
Okay, so another amazing video from one of our Darwin 200 leaders. Now, if you want to see some of those videos as they're being completed and released, you can head over to the Darwin 200 YouTube page. And if you visit, you'll see videos from our Darwin 200 leaders in Tenerife. So as a reminder, they are producing 3 videos while they're teamed up with a local conservation organization, one exploring the issue, one looking at the conservation work that is currently happening, and the third video kind of looking towards the future. What more can we do to help protect? Maybe it's sharks, maybe it's sea turtles, maybe it is an endemic plant species. So all those videos are being slowly uploaded onto the Darwin 200 YouTube page, and you can see what our Darwin 200 youth leaders have been up to. And then if you're tuning in, but you're between the ages of 18 to 25 and you have an interest in becoming a Darwin leader, if you're passionate about conservation and protecting our planet, maybe you're already doing things like tree planting projects, working with a local conservation organization, maybe you've even started your own. You can visit the website, DARWIN200.com, and you'll see a spot for the Darwin leaders, and there's an application form there. And with any luck, you could join us when the Oosterschelde is in one of the ports around the world and take part in the incredible Darwin Leader program. Now, before we turn our attention away from Cape Verde, there's one more video I'd like to share today. This is a tiny little video shared, created by Rodri, one of the amazing cameramen on board of the Oosterschelde. And it is focusing on that lizard that was thought to be lost, to be extinct, but recently has been rediscovered. So let's take a little look at that video before we dive deeper into our event today. All right. So that was some absolutely incredible footage of Cape Verde and our Darwin 200 leader working on that conservation project with that lost lizard species that was believed to be extinct. That is a sneak peek. Obviously, you will see videos coming out from that Darwin 200 leader with narration and such. But we couldn't resist sharing that today just to show off the beauty of those islands and a little bit of the experience that our Darwin 200 leader was having on that project. Now, something that you might not know about Charles Darwin is he wrote, of course, on the origin of species, but he was a prolific writer and wrote many books throughout his time after he returned from his voyage on the Beagle, covering topics ranging from barnacles to the descent of man, to carnivorous plants. And that is what we're going to talk a little bit about today. So our intrepid expedition leader, Stewart McPherson, is boarding a plane as we speak, heading to Australia, laying the groundwork for future projects as the Oosterschelde slowly makes its way around the world. But he was good enough to record a segment for us on carnivorous plants. So we're going to take a look at that segment. And then we're going to have our Kahoot quiz afterwards. So pay attention and be ready. I will share the link and the special pin number for the Kahoot quiz, and we'll see who comes out on top today for the prize. Let's load up that video and let's learn a little bit about carnivorous plants. And actually, before we do that, we should play our curiosity of the week, because our curiosity of the week from last week is a little hint towards what we're talking about today. So that's actually really going to help us. We'll see who came out on top of that curiosity of the week before we look at our carnivorous plant segment. So let's get that loaded up here. And here we go.
I asked you to try and guess what this object here is. Some of you guessed an orchid, some of you guessed a flower. It's actually the pitcher of a pitcher plant called Nepenthes. We have an entire episode next week dedicated to carnivorous plants, which Charles Darwin studied in immense detail. So if you guessed pitcher plant or carnivorous plant, you were right. Well done, and I hope you'll try your luck on this week's Curiosity of the Week.
All right, so we will, every week we're getting more and more answers for the Curiosity of the Week, which is absolutely amazing. I'm going to give a shout out to a few students who sent in their answers. Lots of people had the curiosity correct this week, that it was a pitcher plant. Tobias Gallant guessed it was a pitcher plant, absolutely correct. And Talon Jameson also guessed that it was a pitcher plant. So lots of other people correctly identified it, but this week's Curiosity of the Week is going to be much harder, and we'll play that at the end of today's event before we sign off. Now let's dive into the incredible video that Stu created for us, looking more closely at our carnivorous plants.
Did you correctly identify last week's curiosity as a pitcher plant? That was a bit of a difficult curiosity, wasn't it? Well, this week's talk is all about pitcher plants and other carnivorous plants. This is a chapter of Charles Darwin's work that isn't very well known even today. In 1875, he published a book called Insectivorous Plants. He'd studied these amazing plants for over 15 years and was absolutely fascinated by the concept that some plants can catch and kill insects and other small animals. At the time, people laughed at Darwin. People thought it was a ridiculous idea. There were sarcastic poems written about him and how you shouldn't step too close to a daisy and to other plants for fear of being eaten. But of course, Darwin was absolutely right. Many plants can attract, capture and kill insects and other small animals. The most famous of the world's carnivorous plants is this one here, the Venus's flytrap. Darwin described it as the most wonderful plant in the world. He noticed how its leaves snap shut when an insect goes inside and touches the trigger hairs on the interior of the trap's surface. Darwin was really interested about why plants such as this would trap and kill insects. Before his work, it was thought that this might be for defense, that the plant might kill insects and other animals that might try and eat the plant. But Charles Darwin's work showed that the plants trap the insects not for defense, but to actually get nourishment. He realized that many of the plants that capture and kill insects grow in areas that are really low in nutrients. Darwin's research on carnivorous plants focused on a different group called the sundews, and I have two of them right here. Sundews come in all shapes and sizes. This one produces tiny little leaves, whereas this one is much bigger. If you look really closely, the leaves are covered in droplets of glue that are really, really sticky. Insects get attracted to the leaves, get caught by the droplets of glue and stuck fast like a flypaper. Other types of carnivorous plants catch prey by completely different methods. There are 7 groups of pitcher plants that occur around the world, and these produce some of the largest and most colourful of all traps of carnivorous plants. This one is called a Sarracenia, and it comes from North America. It produces large trumpet-like pitchers that are really colourful, and these colours attract prey just like the petals of a flower. When an insect is attracted, they slip down inside into the mouth of the pitcher and fall all the way down to the bottom, where they can't escape and eventually die. The plant releases digestive fluid that breaks down the body of that insect and then absorbs nutrients that it uses to grow. These pitcher plants come in all shapes and sizes. Among the Sarracenia, some are really tall, such as this one here. Others produce much smaller squatter traps that small ground-dwelling prey can easily climb up into and fall inside. One of the groups of pitcher plants really stands out. This group is called Nepenthes. There's 180 species of them, and they occur mainly in Southeast Asia, and they produce the biggest traps of all carnivorous plants. This is an example, and as you can see, the pitchers develop completely differently. They grow on the ends of these long leaves here. But the biggest species of these can produce traps over 30 centimetres tall, and animals as big as rats have been known to fall inside of them, drown, and be digested and eaten. Many of the Nepenthes produce incredibly intricate pitchers. Look at this one here. This one is called Nepenthes edwardsiana. It has these spectacular blades that cause insects to easily fall inside, but if you look very closely, there's a ring of inwards pointing spines that makes it almost impossible for prey to climb out and escape. Sadly, many of these Nepenthes and some of the other carnivorous plants are critically endangered in the wild. This one here is called Nepenthes clipiata, and it's practically extinct in its natural habitat. There's a collection called Ark of Life, of which this particular plant is one of them, to make sure it survives, at least in captivity, to hopefully reintroduce it one day into the wild. While he was researching this book, Insectivorous Plants, Charles Darwin thought about all of these different groups of carnivorous plants and wondered why they had evolved to catch insects and other small animals. He realized that all of these different carnivorous plants grow in habitats that are very low in nutrients, where the soil is so poor that normal non-carnivorous plants really have a hard time in surviving and growing. He worked out that by catching insects, each of these different groups of carnivorous plants get a benefit over non-carnivorous species. They can survive in the areas where regular plants can't grow, and therefore they've survived, adapted, and evolved. And today, we've got over 800 species known right the way around the world. This week's experiment is inspired by carnivorous pitcher plants. You can make your very own pitfall trap to see what invertebrates you can catch and see if you do better than these carnivorous plants.
All right. Very, very cool. A great and informative video from Stu. Safe travels on your journey down under, Stu, and we look forward to having you joining us live in our next World's Most Exciting Classroom event. As promised, it is now time for our Kahoot quiz. So I'm going to share my screen and let's get this quiz going. So the website is kahoot.it. Lots of different ways you can join. If you're in a classroom and have one-to-one devices like a tablet or maybe a Chromebook, you can head to the kahoot.it website and put in our PIN number 472119. If you are at home, maybe you have your mobile device, maybe you have a tablet, you can scan that QR code and it'll bring you right in front and center. And then we've got 5 questions served up for you today. You have 30 seconds to get each of your answers in. The right answers get you point. The faster you can get those right answers in, the more points you're going to earn. Of course, if you put in the wrong answer, but you do it really fast, well, we've got nothing for you. You need that correct answer. You need it in really fast. Now, I know a lot of classrooms don't have one-to-one technology, so you can join. Your teacher can pop it up at the front of the room and you can shout out your answers to him or her. I can see we've got a few classrooms who have come in here to join us. We'll give it another moment or two, and then we will get started with today's quiz. Now, Stu did mention that our experiment coming up is about pitfall traps, and is such a good fit because, as we learned, our nepenthes, our pitcher plants, use a pitfall trap to trap insects and even things like small amphibians, reptiles, and even as big as rats. And so we're going to learn a little bit about pitfall traps and how you can do an experiment at home as well. We'll give it maybe another 10 seconds to get a couple more classrooms in here and ready to go, and then we will get our quiz started. I should remind everybody as well to use that chat sidebar if you have any questions today about what we've learned so far in the world's most exciting classroom. You can pop them into the chat sidebar and we will answer those questions for you. Okay, I think we're ready. Let us get started. We'll count us in with a couple second countdown. And then remember, you want to make sure you're putting in the right answer, and the quicker you can get it in, the more points you are going to get. So here we go, carnivorous plants. So Darwin studied carnivorous plants for, was it 5 years, 10 years, 15 years, or 20 years? So how long did Stu say that Darwin studied carnivorous plants? Was it 5 years? Was it 10 years? Was it 15 years? Or was it 20 years? Okay, so 15 years was the correct answer for that one. If we take a look at our scoreboard, the genius yak is holding down that top spot. So let's get into our next question. This is a true and false. When Darwin first talked about carnivorous plants, he was ridiculed by the public. So when Darwin first talked about carnivorous plants, he was ridiculed. So people didn't really believe him. They made jokes about it, comics about it. They didn't believe that plants could in fact be carnivorous. All right, that's absolutely true. Good job, crew. Let's check our leaderboard. All right, not a lot of movement, but points coming up. The genius yak is still in that top spot. We have another true and false. Darwin referred to the pitcher plant as the most wonderful plant in the world. Is that true or is that false? Darwin referred to the pitcher plant as the most wonderful plant in the world. Got a few more seconds to get in that answer, true or false. All right, we tricked a few there. It is false. He was talking about the Venus flytrap when he said that. And I put a little clue there in the answer as well with the picture of the Venus flytrap. All right, that shook things up a little bit. Captain Bunny is in that top spot now. We have 2 more questions to go. Many carnivorous plants live in high nutrient soil, in low nutrient soil, deep in forests, or in arid deserts. So many carnivorous plants live in high nutrient soil, low nutrient soil, deep in forests, or in arid deserts. All right, excellent work. Low nutrient soil. So why is that? Well, if you can catch another source of nutrients to go along with the little bit you're getting from the soil, well, that is going to be a huge adaptive advantage. So you often find things like the sundews, the pitcher plants, the Venus flytraps in areas where the soil is nutrient poor. Okay. Genius Yak is back in that top spot, but let's see what happens in our final question. Pitcher plants produce the largest traps of all carnivorous plants. Is that true or is that false? Pitcher plants produce the largest traps of all carnivorous plants. True or false? We've got a couple more seconds to get that answer in. All right. It is true. Absolutely. So let's take a look at our podium. In third place, we've got the Rocky Meerkat. In second place, we have Captain Bunny. And in that top spot, we have the Bronze Bee sneaking in right at the end. Must have been pretty fast getting that correct answer in. So let's come back from that screen share. A huge shout out to everybody who played along in our Kahoot for today. If you were that top finisher, if you send an email to ebtsoyp@gmail.com and let us know, we will send you your Amazon gift card. Doesn't matter where you are, whether you're in the UK or somewhere in North America or somewhere else in the world, it will work anywhere you need to use that gift card. So thanks so much for playing a little bit of Kahoot action with us today. We are going to take a look at our experiment. So 2 weeks ago, we looked at island gigantism. So the example we looked at was the Komodo dragon. Why is it getting so large on these islands in Indonesia? And we also looked at island dwarfism. And our example was this little tiny chameleon in Madagascar that could fit on the tip of your thumb. It would be smaller than the fingernail on your thumb. So two things that we see that happen on islands, things getting really large or things being really small. So let's take a look at the answers and we'll see how our students did this week.
Two weeks ago, your activity task was to put forward your ideas why animals change on islands. Did you work out why certain animals and plants become really big on islands? This is known as island gigantism. Or why other animals and plants become really small on islands, which is known as island dwarfism? Well, the answer is a bit tricky, but let me explain. Well, there's many reasons why this happens. Let's look at island gigantism first. In many cases, remote islands lack large animal predators, particularly mammals. On the Komodo Islands, where our example of the Komodo dragon lives, there are no tigers in comparison to mainland Asia, where tigers are widespread. This is really important for predators, such as the ancestors of the Komodo dragons, because it means that the predators can grow bigger and bigger, and that means they can hunt a larger range of prey. In the case of our Komodo dragons, the fact that they've grown so big means that they can hunt animals as large as buffalo. On small islands, there often aren't as many large species of animals as on the continents, so being bigger in size means a much greater range of prey that the predators can eat. Having a bigger body also often means that predators can live longer between meals. So in our example of the Komodo dragons, these huge lizards can wait weeks in between meals, which is very important on islands where food is often scarce. Similar evolutionary reasons explain why herbivores are often really large on islands too. Think of the Galapagos tortoises. These animals munch on leaves, so they don't need to evolve to become large to hunt other animals. But the second reason, the survival between meals, is very, very important. And this is especially so on dry islands, such as the Galapagos archipelago. These huge tortoises can last weeks between drinks and meals. And on these drought-prone islands, that can be the difference between life and death. Smaller tortoises that can't survive so long would be wiped out, would live longer between their meals. So this goes some way to explaining why they've evolved to become so big. Now let's look at island dwarfism. Could you work out why the Brookesia chameleons have grown to be so small on the island of Madagascar? Well, on different islands, the exact opposite processes can take place. In some cases, it's absolutely within the organism's interest to grow smaller and smaller and smaller. This is especially the case on larger islands such as Madagascar, where there are larger numbers of predators. In this case, the chameleons have grown so small for two reasons. They can hide away and be camouflaged from potential predators. and they could also target small arthropods and insects as their food. So in this case, staying small means they have a better chance of surviving. Did you answer correctly? Let's find out now who won this activity's 3 prizes.
All right, it is in fact time to find out who won this activity's prizes. So as a reminder, each week we have 3 50-pound prizes, Amazon gift cards for the classrooms or the winning student. And the first place this week was Fern from Vermont Common School. And Fern wrote, let's take a little read here. I think the Komodo dragon's island gigantism is because the resources on islands are less plentiful and they need to fight for them. I think the chameleons get smaller for the same reason, but they got small so there would be less competition for resources because they use less resources. So huge shout out to Fern for that great answer from Vermont Common School. We will send that gift card your way. And then also to our second place, we have Lucy O'Neill from Dublin, Ireland. And then third place, Matthias Schmidt from Stuttgart in Germany. So very similar answers. Great work to our groups. And it looks like we had a great spread today from the US, from Ireland, and from Germany. So keep an eye out in your inboxes for those gift cards. Now we are going to look at a new experiment today. But before we do, I want to remind everybody that last week's experiment that we did with the National Marine Aquarium in Plymouth, those answers are due next week. So we are going to take a look at who came out on top in that one, who sent in the best answers. And a reminder, that experiment was pretty cool, looking at ocean acidification. We had our mermaid and our turtle and our lobster helping us out. Our octopus helping us out. And they were blowing into the beakers and they were changing the acidity of the water with the carbon dioxide in their breaths. So you have one more week to get your answers submitted before we announce those winners. And as always, you send in those answers to classroom at DARWIN200.com. So classroom at DARWIN200.com. Today's experiment is looking at pitfall traps and ties in very nicely with our pitcher plants. So you're going to get a chance to do some pitfall traps. Maybe you'll do one in your backyard and you will see what kind of insects you catch. And then you can answer the questions for a chance at the prizes for this experiment. Let's load up that video file and let's take a look at pitfall traps.
This week's experiment is inspired by pitcher plants. We're going to create pitfall traps. These are traps that catch invertebrates so you can find out what incredible little mini beasts live close to your home or to your school. The idea is very simple. It's basically a trap whereby invertebrates fall inside and can't escape. So you can come back the next day and find out what creatures you've caught. Making a pitfall trap is really quite easy. You've got to dig a hole, so having a little trowel is very useful for that. You then need a container into which your invertebrates will fall. This can really be anything. It could be little plastic pots or yogurt pots, such as these. You could also use glass jam jars. I'm going to use these glass scientific beakers, but it really can be any glass or plastic container. The important thing is that the inside has to be slippery, so that the invertebrates you catch can't climb out. You then need a form of bait. I'm going to use a bit of biscuit and some banana peel. So we're going to see if that attracts any invertebrates. It's a good idea to set up a control pitfall trap in which you have no bait at all. That should reveal whether the bait makes a difference. Last of all, you need a cover for your traps. This is very important so that if it rains while you set up your traps, the traps then don't flood and fill up with water, which could kill your poor little invertebrates that you trap. So it's very important to make a cover. You can put a piece of bark or any object that you find out where you set up your traps, but I really recommend cardboard. It's really easy and you can fold down the edges to make a little shelter, like so. Then you can nestle that over your trap So it's really easy for invertebrates to find their way in, but it shelters the trap from the rain. Okay, let's go out and set up our traps. Step 1. Find a habitat where you think invertebrates might live. Forests are great for this, or hedgerows as well. Step 2. Dig holes for your pitfall trap and make sure that the top of your container is the same level as the surface of the ground. Step 3. Put the bait into the traps. Remember, it's a good idea to leave one trap without any bait at all. This will be your control to see how effective the bait is in attracting invertebrates. Step 4. Cover each pitfall trap so it's protected from the rain. Then you're all set. Leave your pitfall trap for 24 hours, then come back and see what you've caught. Please note, I'm doing this experiment in the United Kingdom, where there are no dangerous invertebrates. But if you live in a country where there are invertebrates that can sting or bite you, you need to do this experiment very carefully and under adult supervision. What results did you find in your pitfall traps? Which bait was most successful? Did you notice differences between the invertebrates caught in the pitfall traps with different forms of bait? What about your control experiment with no bait in at all? Did that catch any invertebrates at all? Or were there any surprises or really unusual animals caught in your pitfall traps? Download an instruction PDF for this experiment from the DARWIN200 website and send in your results within the next 2 weeks for a chance to win prizes. In 2 episodes' time, I'll share with you what I found in my pitfall traps. It should be really interesting to compare results from different places around the world. Good luck and see you in 2 weeks' time.
All right, so there is your task for the next 2 weeks, is to build some of those pitfall traps. Maybe try putting them in a few different environments to see if you catch different invertebrates in those different ecosystems. Maybe something like a meadow, maybe your backyard, maybe somewhere in the forest. And of course, don't forget to cover them, because we don't want to hurt any of our little invertebrates that we catch. And it makes it a lot easier to see them if they're not flooded with water. So you have 1 week to get in your results from our ocean acidification experiment, and then 2 weeks now to get in your results for our pitfall trap experiment. We would absolutely love to see some pictures. If you're going to get outside and you're going to make those pitfall traps, please take some pictures and share them online. Maybe you'll do it at home. Maybe you'll do it in your schoolyard. It'd be a great experiment to do with your teachers. If you do take some pictures while you're setting up and then of the invertebrates that you do catch, if you share them on social media, tagging Darwin at Darwin200 or use the hashtag Darwin200, we would love to see some of those pictures of you making your pitfall traps and seeing what invertebrates you are able to catch. Online at Darwin200.com, you will find the video again for the experiment if you want to watch it. You will find a PDF of instructions with the questions that you can answer. And then after you've answered the questions, send it into classroom at Darwin200.com. You've got 2 weeks to get your answers in. And as always, our top 3 answers will receive a prize in 2 weeks when we announce the results from the pitfall trap experiment. So we are running out of time for today's World's Most Exciting Classroom. We're actually going to end a few minutes early because Rodri and Tom were not able to join us. The weather just didn't cooperate. Thunderstorms as they are making their way across the Atlantic Ocean. So it's far too dangerous to be on deck, and even more dangerous to put up a satellite unit on a pole in a lightning storm. So hopefully we will have the Oosterschelde join us live in an uplink next week. We'll have our next event on September 28th at 2 p.m. in the UK, which matches up with 9 a.m. Eastern time. Before we sign off for today, we have one more curiosity of the week to wrap things up. This is going to be a tricky curiosity of the week. So we're going to play it now. And I'll remind as well that we have some time, a little bit of time for some Q&A. So if you have any questions about the Oosterschelde, about carnivorous plants, maybe about something from a previous World's Most Exciting Classroom, use the chat sidebar. You've got about 5 minutes before we wrap up for today, and we want to make sure that we get any questions in that might come in. But let's look at this week's curiosity and let's start thinking about it.
Curiosity of the week are these masks. They're a bit interesting and unusual looking, aren't they? Can you guess what these are and what their purpose is? I've got to confess, I'm cheating a little bit because these are actually cut down in size. The original masks are actually large enough to put on a human head, but they're exactly the same as these, and these were made in the field by the same people that make the full-size masks. Can you guess what these strange patterns and appearances are for?
All right, the curiosities of the week just keep getting better and better. We know last week's was the pitcher plant. Previously, we've had things like shark collars and shell money. So it is really exciting to see what answers come in for the curiosity of the week. Visit classroom@darwin200.com. Send in your answers to the curiosity of the week. And as always, we'll read some of those in the next World's Most Exciting Classroom event, which will be September 28th at 9 a.m. Eastern, which matches up nicely with 2 p.m. In the UK. So we have a lot coming up next week. We'll have a live uplink from the ship. Our next experiment, we're going to observe snails up close and personal. We'll have a special guest to talk about giant snails with us and learn about some of the secrets of how they move. Of course, we'll have a new experiment and we'll have another curiosity of the week. So a huge shout out to everybody who joined us today. I saw people saying hi from Canada, from the US, from the Netherlands, from Barcelona. It is so great to have such a big group hanging out with us. With any luck next week, we will be able to do a live connection from the middle of the Atlantic Ocean if the weather cooperates with us. And the last thing we need to do today is to thank our sponsors. It is so important that we do that because without them, without our sponsors, we would not be able to do the world's most exciting classroom, the Darwin 200, and to bring those Darwin leaders, our future conservation leaders, out into the field to give them the incredible training and hands-on experience. So we will wrap up for the week and we will take a moment to thank our sponsors.